We will start off where we left in the last session, that is regarding the hydrogen spectrum. And I had shown you this slide when the showing that the Bohr's theory could not explain the hydrogen spectrum in all its entirety, but also when applied to multiple electronic systems it failed to account for all the line spectra. So, this is the origin of line spectra what we were talking about, and you can see this is n is equal to 1 and the electrons from here and here n is equal to 2, n is equal to 3, 4, 5, 6, 7 are there, and all of them when they fall to this range n is equal to 1, it gives you Lyman spec series. This is known as Balmer series and Paschen series n is equal to 3, bracket series and Fund series. So, the area of spectrum, visible region and other spectrum, they are all different for n is equal to 1. So, all the things that are visible in the ultraviolet region are n is equal to 1, and all the things that are visible in the n is equal to 2, they are all in the visible region, like that these are near IR etc. The beauty is people first noticed only this Balmer series for the first time, and the later on they discovered these series, Lyman series, Paschen series etc. as our understanding of the spectroscopy improved to higher level. So, in the Summerfield theory there was a slight improvement over the Balmer's theory, that he modified Summerfield's theory to include elliptical orbits instead of the circular orbits. See this slide, we have shown all the orbits as circular orbits. This is the nucleus, these are the electrons, stationary orbits where electrons are populated, and these are all circular. Summerfield modified them into sort of elliptical orbits instead of circular orbits. So, what it means essentially is that the velocity of an electron moving in an orbit will be greatest when it approaches closest to the nucleus and least when it is farthest. So, this was the improvement over Bohr's theory. That also Bohr's theory was somewhere around 1903 or 1912 or something, but subsequently 1916 is fairly long time in the chronology for development of science. But anyway, it came in 1916, and the analogy exists that with the planets, where they also are supposed to undergo elliptical have an elliptical orbit, and when they are nearer the sun, their speed of revolution increases, the speed of movement increases when they are nearest to the sun, and reduces considerably when they are away from the. It all depends upon the major and minor axis of the elliptical orbits. So, the variation in elliptical orbit as a whole has an idea that the nucleus precesses around itself. So, electrons also must be precessing around themselves, just like our planet Earth is going round and round the sun, but it is also going round and round itself. So, this precessional movement will result in small energy changes and will be reflected as fine structure in the spectrum. So, Summerfield's concept permitted the subdivision of Bohr's stationary phases of slightly differing energy levels and corresponding to the difference in the orbital shapes. So, this is the basis of our current modern concept of electronic configurations. Further, it projected the possibility of penetrating orbits. See, the so long as the electrons are moving in an empty space and n is equal to 1, n is equal to 2, there could be elliptical orbits and then elliptical orbit 1, elliptical orbit 2, etc. There could be some sort of penetration because it is all empty space. Okay, the path to be described is only in the space. So, it permitted the possibility of penetrating orbits for different quantum numbers. So, certain electrons may penetrate closer to the nucleus than others. So, thus permitting qualitative pictures of the more complicated atoms. So, nowadays if you take a look at the electronic structure of the atoms in Google or something like that, you will see that highly confusing structure of the electrons where it could be around the nucleus, etc. I suggest you take a look at such pictures in your mobile or in your computer if you have, you will see that they are all fairly complex structures which penetrate each other also, orbits. Okay. So, this is the how the orbits penetrate in the electronic structure. You can see here in the figure the 1s is here and then there is one more here and this is 1s and then 2s, 2p like that and then 3s, 3p, 3d, 2s is here and then 1 is here. So, there is penetration here already. The moment we have the second orbit introduced 2p, 2px, 2py. We will see what is 2p, 2py, etc., 2px, py, etc. later, but now I am still talking about 2p, 2d. Here it is 1s, 2s, 3s and then 3p, 3d and 3s, 3p, 3d, bigger orbitals, and these are known as subshells. This was the contribution of the Summerfield theory, and subsequently this is the rosette path of an electron. That is also very interesting how the electrons can move around in the space. This is a sort of a 3D picture actually, and then the Summerfield's atomic model, obviously it has to describe an axial path and another one is both axes, both are axial paths only, but there could be a movement of the distance to be travelled here for the same angle would be different for the distance to be travelled here for the same angle. Okay. So, you can imagine it is just a mathematical concept which is very clear by itself, we need not explain further. Okay. So, now we come to the topic of electronic distribution in the atoms. So, we know that there are number of electrons as we go up the periodic table. As it is, we know about 108 elements and most of them we know that even though I have not taught you what is periodic table, most of you know that there is something called as periodic table with increasing atomic weight or atomic number, and with increasing either property, the number of electrons in each element increases by 1 unit, and these electrons must be arranged around the nucleus in different orbits, and there are certain rules which have been in practice or which have been observed, and those rules we will interpret a little bit for our understanding. So, these rules actually represent how the electrons are organized around the nucleus in a given space. So, look at this slide now. The electronic distribution in atoms, the first rule we have to consider is rule of 8, that is inert gas atoms with the exception of helium contain 8 electrons in their outermost arrangement. So, helium has got only 2 electrons, that is by nature, but after helium next element to have 8 electrons is in the outermost orbit is neon, and then comes argon, then comes krypton, xenon, radon, etc. They all these things have got 8 electrons in their outermost orbit, that is total electrons would be 2, 10, 18, 36, 54 and 86. So, these things represent the end of various horizontal series of the elements in the periodic table. So, that means the nucleus, most of these elements are neutral elements. That means they are very stable elements, not so reactive. So, whenever there is a multiple of A, there are a rule of 8 is applied, that means when any electronic structure of an element or an ion or an atom or the free radical, something if it gains a structure similar to this with respect to the electrons present around it, if the total number works out to this range, it becomes neutral. So, it represents the end of various horizontal series in the periodic table as far as neutral element is concerned. If the element is not neutral, an element with atomic number 11 may be, if I remove one electron, it will have a 10 electrons, again it comes to neutral level, rule of 8, that means it becomes not so reactive. So, an element with atomic number 12, if I remove 2 electrons, it becomes 10, again it becomes very stable. Like that 21, remove 3 electrons, it comes to 18, like that there are number of possibilities. Many elements which are not just these elements, helium, neon, argon, krypton, xenon and radon, also may become non-reactive or very stable whenever certain number of electrons are removed to obtain the rule of 8 application. So, another possibility is postulated was by C.R. Burry. His name is Dr. C.R. Burry. He postulated that the maximum number of electrons in various shells, that is in the around the nucleus, could be maximum 2, 8, 18 and 32, more than that you can't have. So, that is, these are all based rules based on observations. Okay. So, he also stated that no shell can contain more than 8 electrons unless another shell farther removed from the nucleus is being formed. So, this concept permitted logical explanations for the configurations of the transition and inner transition elements. So, very important concept this one, because the electronic structure of transition elements, it is wholly based on the introduction of electron in an inner orbit without disturbing the outer orbit structure, outer electronic orbit. So, transition elements, lanthanides and actinides, all the 3 series of elements. There are 3 transition elements. If you look at the periodic table, if you are familiar, well and good. If you are not familiar, sometime later I will explain, I will show you those things in a typical structure of periodic table. But for the time being, it is important for us to understand that the electrons can enter an inner orbital as the atomic weight keeps on increasing without disturbing the outer structure. Okay. This is the importance of Bury's postulate, that maximum number of electrons in various shells could be 2, 8, 18 and 32. So, suppose I have an element with 2, 8, 1 and 32, okay, 2, 8, 1 and 32. There are possibilities that 17 electrons can be added up to the third one, okay, because it has got only 1 instead of 18. So, the next electron may go up to 17 to fill up that orbit. So, that is transition elements, etc., etc. So, this process completed or permitted logical explanation for the configuration of the transition and inner transition elements, that is filling up of inner electronic levels, while the outermost orbits remain constant, they do not remain disturbed. So, the electronic orbit configuration based on these two rules. One is the rule of 8, another is the rule of 2, 8, 18 and 32. If I apply this to number of elements having atomic weights, you can see that the symbol here, I have drawn the symbol now, helium, the atomic number is 2. So, the K shell can have only 2 electrons, and when you go to the next one, atomic number is 10, but that 10 can be divided into 2 parts, one is 2 and 8, that is Bury's rule. Now, argon has got 18 and it can go up to 2, 8 and 8 maximum. So, here I have M shell. So, M shell total will have 1 K and L and 1 M shell, total is 18, but it has got 3 orbits. Similarly, krypton has got 2, 8, 18 and 8, xenon is 54, that is 2, 8, 18 and 18 and 8, and radon with an atomic number of 86 is 2, 8, 18, 32, 18 and 8. Now, you can imagine that there cannot be the next element with another 32 or something like that, because we have already reached the end of the periodic table with 86 itself. Okay. So, the quantum designations for electrons are also important, and Bohr-Summerfield concept of electrons revolving around the atomic nuclei is limited to well defined shapes, and it is essentially a rough pictorial presentation. Basically, what we are trying to say is that the concept of electrons going round and round, I had shown you circular figure, elliptical figure and many other figures. So, even those orbits and orbital paths are only a rough pictorial presentation of the actual electron being there around the nucleus at a particular space and time. That is the essence of quantum mechanics. Okay, you cannot predict the position and momentum of a particle at any time exactly. There is always certain amount of error by the time you predict the position, momentum changes, momentum you predict, the position changes, and that minimum approximation is approximately about h by 2 pi or something like that. But then essentially that means the electrons will tend to group themselves in a series of positions relative to the nucleus, which may be considered as energy levels, yes, but those energy levels are with respect to the nucleus. So, transitions are permitted only between these energy levels which are present around the nucleus, and the energy levels are also not exactly defined, but they are all our imagination, that if an electron is at such a particular height or distance from the nucleus, its energy level could be this much. If it is more, its energy level could be this much, like that, but they are not exactly defined. You cannot see them in actual figure. So, these energy levels, how do we infer them? Is by spectrum. That is the beauty of spectrum, and every electron in an element can be described in terms of its quantum numbers. One is principal quantum number n, another is orbital quantum number L, third is magnetic quantum number m, and fourth is the spin quantum number s. So, n, L, m and s are the 4 quantum numbers, and the energy levels corresponding to the orbit n would be something like this: W is equal to minus 2 pi square z square e to the power of 4 into mu divided by h square multiplied by 1 over n square. So, this term is not very important as far as your course is concerned or exam is concerned, but it is good to understand these things. Here in this equation, W is the energy of the electron and Z is the total number of electrons, that is atomic number, and E is the electronic charge, the e raised to 4 is here, and mu is the electronic mass, that is here, okay, and h is Planck's constant, that is here. So, Z is the total number of electrons, that is atomic number. So, crudely this amounts to the mean distance of the electron from the nucleus, which one? W is equal to minus 2 pi square z square e to the power of 4 mu into 1 by n square divided by h square. So, the principal quantum number, I can have n is equal to 1, n is equal to 2, etcetera, up to n is equal to infinity, but infinity means it is not there. Okay. The electron must have escaped. So, infinity refers to the complete removal of the electron from the influence sphere of the nucleus. That means, it produces a positive ion, and they may be the paths described by the time they start from the lowest energy level to next highest energy level until it reaches the escape level. They can be designated as K shell, L shell, M shell, etcetera. So, now we will describe what is L. Earlier I described n is equal to 1 to infinity. Now, in the previous equation we have not written L, but the second quantum number, that is orbital quantum number L, is another address for an electron. That is, any electron can be given some numbers corresponding to n, L, m and s. Okay. So, the orbital quantum number L is a measure of the orbital angular momentum of the electron, which is a vector quantity. So, what is a vector quantity? Find out. Okay. I may ask you in the exam. So, better find out what is a vector quantity. So, if L is a orbital quantum number, that is h into square root of L into L plus 1 divided by 2 pi, and the values of I, values of L may vary from 0 to n minus 1. That is, if n is equal to 2, L could be equal to 2 minus 1, that is 1. N is equal to 1 means L should be 0. That is the energy of the material or the electron corresponding to n is equal to 1. So, when n is equal to 2, the value of L would be 0 and 1. So, n is equal to 3, it goes to 0, 1 and 2, L is equal to 4, it goes to 0, 1, 2, 3, etc., etc. So, customarily these levels are named after the spectral terms that are obtained in the spectrum, and in the spectrum we define the spectral terms as S, P, D and F. Okay. So, they are the jargons of spectroscopists. The spectroscopists describe it is S, S means L is equal to 0, orbital angular momentum, and P is means L is equal to 1, D is L is equal to 3, F is L is equal to 4, etc., and the electrons present in these orbits are referred to as SPDF electrons. Okay. Now, a wave function is associated with orbital motion of an electron, that is called as orbital. The electron being very small, it will not be moving like a cannon ball or a pistol ball, but it will be moving like a wave. And yesterday I have told you that the movement of a wave can be described by what is the height of the wave, what is the distance of the wave, what is the number of cycles or how many cycles are completed per minute or something, that is frequency. So, the wave function of an electron which is in orbital motion of an electron is called as an orbital. So, we have SPDF orbitals also. So, what we have now, whenever we are trying to describe the electrons atomic structure, we say SPDF electrons are there, S electrons, P electrons, D electrons and F electrons, but we also say there is a S orbital, P orbital, D orbital and F orbital also. So, S electrons are there in S orbital, but still the electrons are also referred to as SPDF and orbitals are also referred to as SPDF orbital, just to distinguish them from each other. Okay. Now, here is a picture of the hydrogen atom electron orbitals. Okay. For magnetic quantum number m is equal to 0. So, here again we have shown n is equal to 0 means n is here I see only one orbit, n is equal to 2 means 2 are there, n is equal to 3, it is like this, n is equal to 4, you can make out, n is equal to 5, but here in this case, in all these cases L is equal to 1 here, right from n is equal to 1, here it is n is equal to L is equal to 0. Why? Because n is equal to 1, L should be n minus 1. So, this orbit is defined as L is equal to 0. Similarly, if n is equal to 2, L should be 1 and there is no possibility for this to be L is equal to 2. Therefore, I have the orbitals when L is equal to 1, I have an orbital arising from n is equal to 2, orbital arising from n is equal to 3, orbital arising from n is equal to 4 and orbitals arising from n is equal to 5. Similarly, when L is equal to 2, L is equal to 3, L is equal to 4, all these possibilities are there with respect to the electronic orbitals. So, the magnetic quantum number, now we are going to define, is not easily visible in our day to day life of a spectroscopist or a physicist who wants to look at the electronic structure, but only when you put a magnetic field around an electron, then you will see some effect in the spectrum, not around the field. Okay. So, what is the effect? The spectral line which is one single line will appear 2, instead of 1 it appears 2. Okay. So, one single spectral line appears like this. They could be parallel, not necessarily originating from the same point. They will appear as 2 parallel lines in the whenever a magnetic field is applied. So, this effect is known as Zeeman effect, a very important concept in atomic absorption as well as in many other systems where I have taught earlier, and especially atomic absorption and atomic ICP, inductive coupled plasma. So, this is known as Zeeman effect. The orbital angular momentum vector, it undergoes a precessional movement that describes a cone. Okay. Now, look at it like this. The orbital angular electron is here. The moment I put an electron, you can see here I am turning a little bit. So, it will start moving around. So, the precessional movement of the electron describes a cone. The cone means you know what is a cone. So, cone means it is a cylindrical thing from the bottom. It is like a small packet of paper packet what you get in ice cream. Okay, ice cream cone you are all very familiar. So, you can imagine an ice cream cone sharp at the bottom, open at the top, but it is going round and round in that space. So, it describes a cone about an axis in the direction of the field, and the magnitude is given by m l into h by 2 pi. That means, the area of the cone on the top where maximum area is there, that is given by m l into h by 2 pi. So, it keeps on going like this. So, there are 2 l plus 1 magnetic numbers ascribed to each l orbital. So, for electron s electron, there l is 0 and m is equal to 0. Because why? Because 2 l plus 1, 2 into 0 plus 1 is 1 only, is not it. So, there is only one orbital, but the corresponding magnetic quantum number is 0. So, for p electron, l is equal to 1 and 2 l plus 1 means there will be minus 1, 0 and plus 1, and why minus 1 means it is only a positional effect. So, with respect to particular measurement axis, so if it is below minus 1, if it is above plus 1, and if it is on the same place it is 0. So, I have minus 1, 0 and plus 1, and for a d electron I have l is equal to 2, and that means 5 orbitals are there, minus 2, minus 1, 0, plus 1 and plus 2, and f electron also is there, that is l is equal to 3, it has got about 7 orbitals. So, we will describe about the spin orbital, the spin quantum number in our next class, which has something to do with the electronic spin. So, what we have described so far is how an electron in a given system can be defined individually. Every individual electron can be defined by 4 quantum numbers. One is n, one is l, one is m, one is s. We have understood what is n, principal quantum number, l is angular quantum number, m is magnetic quantum number, which is visible only on the application of magnetic field. We will continue our discussion with respect to spin quantum number and complete our understanding of the electrons in the next class. Thank you very much.